What's good, Year 11 General Math Goers? Mr. Herman here, and this lesson, Lesson 5, is looking into Exercise 6E, finding the equation of a straight line using 2 points on a graph. This is different from the previous exercise, Exercise 6D, because we're now just solely using 2 points without being given what the y-intercept is. So you remember that the format y equals a plus bx, the a was the y-intercept, and the b was the slope. This exercise here is going to be looking at finding the slope. The slope part is really simple, but finding the y-intercept when only 2 points are given. They don't tell you, hey, here's the y-intercept, this is your a value that you're going to substitute into here. That isn't being readily available. And there are ways around this. There are, in fact, 2 methods that we can use in order to solve how to figure out a. They are a bit tricky because there is a bit of algebra that is involved. But as long as you can follow this process, the step-by-step process, you should be fine. And alternatively, you can use your class pad calculator to help you out by using the solve function. We'll get to that in the example. For now, this is a step-by-step guide for method 1. The first thing we're going to do is we're going to write the general equation in the form of y equals a plus bx. So this is the general form. What we're looking for, obviously, is a and b. First thing you're going to do, step number 2, is you're going to look for the slope. What b is, you're going to look for the slope. And this is easily done by getting 2 well-defined points on that line, or 2 well-defined points, or not even well-defined points, 2 points that the question just gives you, label them x1, y1, x2, y2, and just do a simple substitution straight into here. This will give you your b, your slope. That's the easy part. The next step, once we, this step here just talks about substituting it into there. The next step is to find the value of a. And what you're going to do is you're going to substitute one of the points on the line, or one of the points that have been given out of the 2, and we're going to substitute that into this equation here to solve for a. So what will happen is, say for instance we use a certain point, it's an x and a y, it could be x1, y1, x2, y2, it doesn't matter. Grab that point, substitute it into this equation here. Wherever you see an x, replace it with a number. Wherever you see a y, replace it with a number. And our b would have been already solved from the previous step and substituted here. What will be left is just this letter a and a little bit of algebra tidy up. But this should be able to give you the a, which you will then substitute back into the equation to get your y equals some number plus minus some number x. Okay, bit confusing without having to see the example itself. Method 2 looks pretty much the same, but the only thing that's different is that the equation that you're going to substitute the values into, so you find your b by the rule, 2 well-defined points, get your b. But then we're going to substitute it into this formula here. Alright? And specifically, we get our x1 and we get our y1. Substitute it into here. We also have our b value that we found in the previous step. Substitute it into here. Do a little bit of algebraic magic, and you should get equation again, which is in the form y equals some number a plus some number b times x. Now this one, step 2, is a bit trickier to do because of this minus y1 that we have tagging along, and we have to do some rearranging or transposing. But in saying that, it can be done with a bit of patience. We'll look into example 1. We're going to find the equation of a line that passes through the points 2, 1, and 4, 10 using method 1. So it's specifically saying, hey, use method 1. So our first step is to write the y equals a plus bx. Now another thing you should notice that I should do as my first step is get into the habit of labeling these points. This is, let's get rid of that. This is x1 and this is y1. This is x2 and this is y2. So x1 being 2, y1 being 1, x2 being 4, and y2 being 10. We need to do this in order to get our b value, our slope, which is b being equal to y2 minus y1 over x2 minus x1. So it just makes it easy for us to determine which values we have to substitute in. So our y2 in this case is 10 minus our y1 value, which is 1, over our x2 value, which is 4, minus our x1 value, which is 2. 10 minus 1 is 9, and 4 minus 2 is 2. So 9 over 2, this as a decimal is just 4.5. So our slope is 4.5, or in other words, for every unit that goes across 1 on the graph, it goes up by 4.5. And I know it's going up and not down because there's no negative. There's a positive here. Okay, so it's positive 4.5. So that is our slope. That is the easy part, which is extracting numbers and putting it into a defined equation. The next part is saying that we need to substitute the coordinates of one of the points, and we get to choose one of the points, either will do, and solve for a. Or in other words, let's call back that equation again, the y equals a plus bx. We know what our b is. So instead, the equation so far will now look like y equals a plus 4.5x. And the step is saying, choose one of these points. I'm going to choose 2, 1 because it's lower numbers. And instead of x within this equation, we're going to substitute it for 2. And instead of y in this equation, we're going to substitute it for 1. So this not necessarily rearrange, but this new format of the equation should look like this. 1, so y is equal to 1 in this case. 1 is equal to a plus 4.5, and now remember this is a times, because 4.5x just means 4.5 times x. What this x value is, which is 2. And the only pronumeral you will have, the only pronumeral or letter that you will have by itself is a. So the next step is something can be solved. 1 is equal to a, that's still going to remain the same, but we know what 4.5 times 2 is. This is 9. Or in other words, 1 is equal to some number plus 9. I'm now going to do a little bit of algebraic rearranging to get a by itself. There is a plus 9 that's associated with it, so I'm going to subtract 9, and whatever I do to one side, I do to the other. As a result, these two get cancelled, and what I'm left with is a is equal to whatever 1 minus 9 is, which is minus a. Now we have got our a value. So that's not the end of the question. The question is, find the equation of the line. So we need to put it into the format y equals. So our equation in this case, we know what our a is, minus 8. And we know what our b is 4.5. So our equation in this case is y is equal to minus 8 plus 4.5. And this is what we do for method 1. Now, here at this point, here, you can technically get your calculator out and use the solve function in order to answer this for a, and it will automatically spit out minus a is equal to minus a, and we can just go straight ahead and put that into the equation. Now let's look at the second and final example, and here we have this question here. Find the equation of a line shown in the graph using method 2. This is kind of one of those questions now where you're totally in the dark now, because no points are given, no y-intercept is given. You kind of have to figure out 2 points to use and substitute it into an equation. Okay? Alright, so apologies, phone's just getting a bit annoying. Find the equation of a line in the graph using method 2. Let's look for 2 points. There's this point here. So when x is equal to 1.5, our corresponding y value is equal to 8. That's our first point. Second point, we're going to use this point here. I know it's tempting to use that point even though it doesn't necessarily hit 2. So we're going to use this point here, which is when x is equal to 4.5, our corresponding y value is equal to 1. So when x is equal to 4.5, y is equal to 1. So 2 points, that we're going to use is 1.5 and 8 and 4.5 and 1. And we're just going to label this as x1, y1 and x2, y2. We are expecting a negative b value or a negative slope because the graph from left to right is going downhill. So y equals a plus bx. Let's find our b value first. So our b is just y2 take y1 over x2 take x1. Our y2 is 1. Take away our y1, which is 8. And that will yield our negative answer. Our x2 is 4.5 and our x1 is 1.5. Okay. In this case, 1 minus 8 will give us negative 7. And 4.5 take away 1.5 will give us 3. So in other words, this graph, every unit that it's going across by 1, it's going down by 7 over 3 units, or it's going down by 2.33333 recurring. So we got a b value. Yippee! Now, method 2. And we are going to use a class pad calculator to help us with it. I did say, I think, previously that you only use it for method 1, you actually use it for method 2. Method 2 says, substitute the value of b, which we just found, and y1 and x1 into this equation here. So y minus y1, so our y minus y1 is equal to b, comma, x minus x1. And technically, it doesn't really matter which one we substitute into here, but for the sake of consistency, let's use the 1.5 and 8 because that's our x1 and y1. So y minus our y1 in this case is 8, so I'm just going to put this in a different color. 8, indicate I got it from there. And this is going to be equal to, we know what our b value is. This is negative 7 over 3, comma, inside there, comma, x minus, and our x1 in this case is 1.5. Now, we have this really, really ugly looking equation. Okay, we've got these negatives, we've got these decimals, we've got it in a weird format, and this is where our solve function comes into play. Okay, I've got my calculator up. So we've got this weird version here, and we just want this to be in the form of y equals and then some form with an x. Now I know it's easy to just say, oh hey, how come we can't just plus x on both sides? You technically can. That still wouldn't put it in the format of y equals a plus bx, because we've got these crazy brackets going on now. So this is where we're going to use the solve function within a class-wide calculator. So what you're going to go do is get your calculators out, go into main, and in main, with the keyboard setting already up, if not up, just press keyboard within your little dashpad. You're going to click on the solve function, and you're literally just going to type this equation in as is, making sure you're putting this as brackets, or bracket as fraction, rather, or as a fraction. So this is going to be equal to, now your buttons will have X, Y, and Z on the top, so you will just use them. Mine, I'll just use my keyboard. Y minus 8 is going to equal, then I'm going to get my fraction button, which is again in math 1, negative 7 over 3 plus, and this is going to be times. Just be safe and put the times in there. My times looks like an asterisk because I'm using my emulator. You'll just use the times on your keyboard, open bracket, x minus 1.5 close bracket. So all we've done in here is we're telling, hey, calculator, I want you to solve this equation here. You'll notice that there are two variables, y and x. We wanted to solve for y. We want it in the format of y is equal to. So to tell it this, we put a little comma, which was in a little trackpad, and we're just going to put comma y because that's what we're solving for. We want it to show y equals. If we put comma x, it's going to show it as x is going to be equal to yada yada. We don't want that format. We want it in the format of y equals. Execute that, and you will get this form here. Now there are two different answers that we can approach to this. This is a y is equal to negative 7 over 3x, so just put the x on top, plus 23.2. If the calculator tells you that it wants it in decimal format, you're just going to make sure that where it says here standard, you press this, whatever it shows will give you that form of answer. So now that it's showing decimal, if I just execute that again, it's going to show the decimal format, and hopefully the question should tell you how many decimals to round to. So in this case, our y is equal to minus negative 2.33. For traditional sake, it's usually 2 decimal places. Negative 2.33x, or times x, plus 11.5, and that will be our answer. So I'm going to write both answers there. So our y is going to equal negative 7 over 3x, negative 7 over 3x, plus 23 over 11, 23 over 2 rather, or if it asks you for decimal format, you will write this as y is equal to negative 2.33 plus 11.5. Whoops, forgot the x. Backspace out. X. There we go. Plus 11.5. And those are the two formats that you can write it in, depending on what the question asks, or if the question doesn't tell you, you can choose any two. The traditional format is to leave it as fraction. It just depends on what fractions you get. But if it says decimal, round it, and it tells you to round it. You round it to what it's asking for. 20 minutes. That concludes this exercise. It's one of the trickier ones. You will get introduced to all these different formats that you can play around with equations and straight lines. It does hold its purpose, and that will be context later down the track. Final thing that I want to say is, before I go too far, 6E. This will be the final exercise that we'll be working on before we start the first assessment. The first assessment is going to be looking at 6A to 6E. You will get more details about that in the future. Until then, stay safe guys, and I will see you in the next video. Bye.